JAKKS toys. There he is.
Hello.
What's going on, Ellie?
Just another day in paradise, right?
Just another day in paradise. I like it. Well, you got the benefit. You can roll right out of the chair into the bed right there, it looks like.
Yeah, it's my home office.
Listen, we all need... I've been there. I'm not kidding. When I was first learning ZBrush, I was standing at a desk. Like, I would literally just turn my chair and roll into bed. Like, when I was done at night. I'm not kidding. I would literally do that. It was the best. Well, Ellie, I'm excited to have you here. Share a little bit about who you are so people know who you are and where you're coming from as a background as well as a ZBrush user.
All right. Well, hello. I'm Eleazar Carmeli. I'm Direct Sources, Sculpting and 3D Design at JAKKS Pacific Toys. I've been in the toy industry for about 15 years. Worked for a number of companies, Dr. Fresh, Mattel, now JAKKS. Let's see, I've done so much stuff. It's kind of hard to pick one. One thing I want to talk about today is my workflow and how I utilize ZBrush. I have what I would call a very hybrid workflow where I see ZBrush as integral to that workflow and how I use it with my other tools, my engineering tools, and back and forth between the two. I believe it's important that you use tools to achieve your goal. You don't make your goal to use tools. So every tool I can use, I will apply, and ZBrush is definitely one of those.
Awesome. Well, again, we're excited to have you here. You got a lot of great stuff to share tonight with everybody. So I want to get into it. You have your screen ready. Do you want to get into showing your ZBrush and your screen right now?
Yeah. Okay. Let me just jump to my screen.
Look at the guys in the booth. There you go.
All right.
Your the JAKKS logo now. Your presentation.
Okay. Apex Legends. So this is one of our biggest recent releases that we just put out, and I worked on all of these. And one thing I really wanted to cover is working with licensor assets. In the toy industry, it is very common. You're going to work with licensor assets. That's where they have game data or movie data or whatever it is. They're going to hand it off to you, and you got to make that into a toy. It's not just opening and exporting. There is quite a bit of work involved on that. You know, show you an example. This is our 6-inch figure. And as you see on the left, that's the actual game data right there from the game. And when you go to take that into an actual action figure and shrink it down to 6 inches, things aren't exactly the same anymore. Reason for that is that toys are made on big giant machines like this. This is a CNC. It's a 5-axis CNC. It's going to carve a big block of steel, and you're going to have like these cavities that you're going to inject plastic into. So for that reason, when you go to make toys, the point of view that I have is that I want it as close and as ready to go for my engineers so that they don't have to make certain decisions. And then other things that get involved with it, things like, for instance, your tolerances, your wall thicknesses, your flow, all these things are important things to consider when making toys. So let me just pull up this one. This is Wraith. And this is the actual, I believe this is our stage 1 production. And you can already see when you look at it some of the changes. So if you look, for instance, the hair and part of the scarf, those thicknesses. And when you look at it up close, it's like, wow, that's pretty thick. On a 6-inch figure, that is bare minimum tolerances. Now, how do you figure these things out? So when I work in ZBrush, one of the first things I do is I set scale. Scale is very important. You know, utilizing tools like Scale Master or even the 3D print tool to export and run it through your other tools and bring it back in, whichever way you want to handle it. And I like to bring in a reference object, something that gives me an idea of my bare minimum tolerances and wall thicknesses, so I can at least check things and start to make decisions on how I want to adjust this to be manufacturable and also be functional as a toy. one thing I have right here, let me just go up to it. This is a 0.65 of an inch sphere. Pretty easy to do. Just make a sphere, either scale master it or the 3D print exporter as a 0.65. That's going to be your ideal minimum wall thickness. And what's great that once you have this tool, this that you could bring in, this reference sphere, is that you can then go through your model and you can check it in places and make certain that your minimum wall thicknesses are going to be at that thickness. Other things going to be detail. So your minimum detail on injecting plastic, really you're going to be looking between a 5/1000th to a 7/1000th of an inch, and that's going to be so thin that you might even need to etch that into the mold. So you really want around 10/1000ths and above. So export out a sphere at around 10/1000ths. That's what I have here. So this is my 10/1000ths reference sphere. Bring that on out. As you can see, it's pretty small, but when I'm sculpting something, I need to check and make certain that whatever detail I'm putting in there is actually going to be manufacturable. That's important to have on there. So, pull up the next model.
So that's just a couple spheres that you always use for yourself for your referencing point to make sure you're getting your right depths and right sizing.
It's going to take just a moment. Nope, here we go. And Bloodhound.
Wow.
Yeah, this guy's a lot of work. And let me point out a few things, areas where adjustments had to be made. If you look here on the hat, for instance, you look at some of these details, the dangles, some of these wall thicknesses, and let me jump back to this. So you can see the game data and you see the production. That's where adjustments have to be made. That's where the eye of the artist comes in, and you have to make decisions. And to me, it's very important that a sculptor makes those decisions before an engineer makes it. If you're going to leave it in the hands of the engineer, they're going to do everything they can to make it, but really, that's your job in the toy industry. Make this look beautiful, make it functional, and make it producible. And you see right here, here's my reference spheres, so I could check things. As you see also on my subtool palette, do yourself a favor when you go to make articulated toys or you're doing toys in general, put things in folders, name those folders, because you're going to have instances where someone's going to come in and be like, I want to see this part. Can we, have a quick look at just the arm or just the leg? You don't want to have to sit in there turning things on and off one by one for forever. Put them in folders. Let's see. Okay. Yeah. So one of the things that I do a lot with ZBrush in my workflow is posing parts of figures after I've already got them all sculpted up. Going back and forth between my engineering programs and my sculpting application, ZBrush, there's going to be times where we change out parts, like for instance the accessories, and making certain they fit and then posing them up. ZBrush is truly one of the greatest things for posing these models for myself. I find especially with odd topologies. Let me just show you right here. So this will give you an idea of what some of these topologies come through with some of these engineering programs, going back and forth between them. And ZBrush handles these type of ugly meshes so well. Show you an example. Quick tip: when you go to do these things, duplicate your tool. You always run a situation where it's like, damn it, I wish I had the original one for one reason or another. Duplicate it. Don't do that where you're running out and having to go backtrack. So I'm going to pose up this finger real quick, and as you can see, I actually have it grouped. I'm just going to go ahead and undo that. I personally like using the lasso tool when I do my grouping. Especially when you do fingers, and here, let me do this real quick. Now I can see it. Make certain you check both sides of the fingers or legs or whatever it is. I see this sometimes where, and I've even done it myself, where you go through and you draw up part of it. And you're like, oh, that looks great. And you turn around the other side and it's like, damn it, that's terrible. Check both sides. And I missed that.
So you're doing this on the mesh you brought in. Is that right? That's what you're doing this on right now?
Yes, this was actually a mesh that was partially sculpted in ZBrush and ran through my engineering application. So that's where I want to show really one of the magic tools of ZBrush and how it handles dealing with meshes like this in this scenario. So I'm going to just go ahead and pose this this finger a little. Let me just go ahead and rotate it out. I turn on transparent so I can actually see where the finger's sitting. One little tip also with soft shore PVC, give it a little bit more squeeze than you think. It's going to have some give in production. And the last thing you want is a hand so loose it's dropping the accessories. Just give it a tiny bit of squeeze. Some degree, you may have to play back and forth on it. That's part of toys is trial and error. So let me just go through and get that trigger finger, last proximal. Come on. There we go. All right. So as you can see, this is a little bit ugly in places. It's not terrifyingly bad, but it definitely has some stretched polys. Now I can go through and dynamesh it, which isn't bad depending on your settings. But if I just want to clean up this little section here so that I can resculpt and fix it and make it look better, one thing I found that works for me, let me draw my size down. I use Sculptress. I turn on my smoothing, and then right here under Z intensity, I turn it way down because I don't really want to necessarily change the overall shape. I just want to change this topology. So just go ahead and so now that I've kind of fixed some of that topology, I got a little bit more going on there. It's more even, it's not so stretched. Now I can go through, turn this off, and then start sculpting away, cleaning up anything that just didn't come out right.
How fast are you having to do these pieces? Like, what's your time frame that you're getting from like concept and then getting to the final piece?
Depending. I mean, that's some of that's kind of on more of an internal deadlines, but I'd say from start to finish, it's about a day and a half.
Okay, a day and a half from start to finish, the entire thing.
Usually for me, I'd say it's about a day and a half. Depending on what is the complexity of the model, how much detail. On average, a lot of these, that's usually how fast I zip through it. If I have to start doing a lot of articulation on more of the engineering side, yeah, maybe add another day, but it rarely takes for me more than 3 days.
And then when you're done this, do you worry about remeshing it or anything, or you just decimate it and then send it for print?
Depending on where I'm going with it, before I send this off to my engineers, it has to be a clean mesh. I'll tell you right now, looking at this right here where you have this intersection, engineering programs sometimes will not understand this intersection. So you should either remesh it via either Dynamesh or smooth it out, whichever way you want to handle it. you have to have a good, solid, closed manifold mesh when going to the engineering side. And that also affects for 3D printing as well. I'm certain people have experienced things where they do a 3D print and they don't know why they had some weird cavity or some sort of weird hole when you check your mesh and it says, hey, everything's good. It's because you have things like this where I know somewhere in the intersection here, let me see if I can actually show it. Turn on double. Yep, right there. That would be a problem for an engineering application or for a 3D print application. It's pretty small, so a 3D printer probably would pass it. But if you go to machine this, you go to tool it, it's not going to know which face is which on the outside. So that's where you'd want to actually do a Dynamesh, remesh it, make certain it's a perfect closed manifold object. Let me just undo that.
What do you think is the best way for someone to get in the toy industry if they really want to be in the toy industry as a ZBrush user?
I'm sorry, say again?
What do you think is the best way for someone to get into the toy industry that is a ZBrush user?
I think do a lot of trial and error. When I talk with someone that's coming up into toys and they use ZBrush, I want to know that they have sculpted a ton of things and they've printed stuff. And they've seen the problems. They've seen where they failed and where they learned from those failures and moved on and learned how to fix those things. That's going to be the number one thing. When you work in toys, it's a physical object. And it's not just a physical object. It's a tiny physical object. So you have a lot of challenges in that sense.
How do you get the files as an engineer? So when you go to the engineering CAD programs, what are you converting them to? What are you giving them?
At that point, we're either going to be sharing STL or proprietary file format.
Okay.
We do always keep a copy of the ZBrush file in case we have to go back to it. But just because a lot of engineering applications are very specific on what they accept, we usually aim towards STL. OBJ, personally, I'm not a fan of, only because sometimes it has issues with applications. What I've noticed with OBJ is that depending on if it's a quad mesh or a triangulated mesh, sometimes a CAD application will have to triangulate it, and it gets kind of funny. Where if I send an STL, I know it's going to work. Let me go to the next one. Okay, so one thing that I get a lot, and in the toy industry, you just deal with a ton of this, and that is licensor assets, be it either game data or animation data, and you got to take this and shrink it down and scale it into something that is usable within a toy. One of the things that I try to always present to people is topology. What you output from this program is what's going to be machined. It's what's going to be tooled out and essentially show up in a toy. Meaning, if you give your engineer, for all the tooling guys, a file with these big, heavy facets, that's what's going to show up. So you need to make certain that what you actually give is properly tessellated and smoothed out, and even more importantly, matches the actual intention of the licensor. ZBrush has some very amazing tools for automatically doing this. Now, I'll show you real quick. If I go and I just go through and divide this up, it'll smooth it out. But it also kind of loses some of these hard edges. Those, I really want to keep those sharp edges, especially if this was something that I knew was supposed to have, a nice hard sharp here. Let me just change this real quick. So
you're going to disappoint some people. They really love the red wax, some of
them. For me personally, I have a hard time seeing the red wax.
Yeah.
I don't know why. When I'm sculpting, my favorite thing to do is to use skin white, turn on polygroups, polyframe, and then turn off the draw.
Yeah.
So that I see the colors.
Yeah.
I don't know why. For me, this is easier to
No,
see.
I've noticed that honestly for a lot of toy people. I've noticed a lot of toy artists will do that. Actually, they'll do that exact same thing too. They'll go to a bright material, turn on polyframe, and turn off the line.
I think it's because we're dealing with these very small tolerances, and we're trying to look for these type of edges and things. In this case, where I want to try to preserve these hard edges from this very low poly model, a great tool you have under poly groups, if you go to group by normal, there you go, automatically does that. And I can come through to geometry, to crease polygroups. Now if I go to smooth it, let's do the dynamic. That kept those nice crisp edges. So now if I go through and I go ahead and apply this, so let me go here and apply it. I usually like to take it up a little bit higher than this when I go to export it to my engineering, just because the engineering is going to do its own thing to it. So you might as well just go ahead and run it up a little bit higher. In this case, if it was just this part, I would actually go as high as 1,000,000, just because when it converts the engineering application, it does its own thing. So you might as well run it up if your computer can handle it. And then this would be ready to go out to there.
So the question about the time, just to reiterate, is it start to finish? You're saying you said a day and a half from start to finish, or from like a licensing file? Like you've got a licensing file and now you're just making it into a toy? Or no, from scratch is taking you a day and a half to make
on the licensing file, I'd say about a day and a half. On a ground up file, and this is going to vary for everyone, and this isn't specific to the toy industry, it's just how I work. I will do anywhere from 1 to 3 days. And that's really just the way I work. Everyone varies. Some people take a little bit more, some people take a little bit less. I don't think they ever have something in the toy industry. I've never seen anyone demand it has to be done in a very specific amount of time. It's more of like they just schedule it out and you get it done. The most important thing is that it looks good, it functions, and it's fun. We're making toys. They got to be fun.
Do you have to work with IGS files at all?
Yes. Yes, I do. CAD files quite a bit. And actually, that's something I'm going to show in just a moment of importing CAD files.
All right. Awesome.
So something that I get a lot, and I'll bring in one real quick. Go ahead and skip that. And by the way, I absolutely love it that you guys incorporated the STL import into the default import, so I don't have to go through the 3D Print Hub anymore.
Yep.
So this is essentially a CAD mesh.
Yeah.
And, it's not bad for a CAD mesh. You can see these ordered triangles. This is actually, decent. This type of stuff is a mess. But, if it was just a CAD file, that's fine. But let's say you bring this into ZBrush and you need to do something with this. You need to, for instance, raise up some of these sections. And this can be difficult to work with. Now, what's great is that polygroups, that group by normal, this functions on here too. Already just by automatically, it already took up all these faces. And, if I need to adjust it a little bit more, a little less, you can go through and adjust that slider. So I can start make adjustments on this. Or if I have to integrate this into any other application, it's great to have that. Now, this is an instance where it's a fairly easy to understand mesh for the software, for the default setting to read. But let's have a look at something which I actually deal with a lot, where things have been bouncing around between different applications, and you get a damn ugly CAD mesh.
Mm. Oh, yeah.
This one is definitely not pretty.
Mm-mm. Mm-mm.
And this is something actually you see a lot in toys, where a CAD file gets bounced around between multiple different applications, and you get something like this back. And you got to do essentially what I just did. Well, if you go to use the default group by normal, it's probably not going to work. It's probably going to either miss something, or it'll just take a moment. It's got to think about it. And you can see it got a few things. It's kind of impressive, but it didn't really catch everything that I wanted to. But if you look right here on that tiny little ball and just click on that, switch it from volume to surface, and then hit it, it's going to use a different algorithm on there. And there we go. Now it's giving me all those polygroups on all the different faces that I had before. It's going to definitely do a few weird things here, but it's helping me get to where I want to go. And I can sit there and start messing with these individually as I want to go around. Normally when you're dealing with IGES files, I would tell you when you're dealing with CAD files in general, IGES is a surface format, and it's actually a surface format based on curves and points. And depending on how the person writes it, it can be a hot mess. If you have the option, ask for STP. If you got to tessellate a step, you're going to have way better results than an IGES 90% of the time.
Can you do me a favor? Can you hit Shift M, as in magnify, Shift M? It's my new favorite, right? Yeah, there you go. They want to see that. So that's what he's using to assign the new polygroups, and that's the little circle he's talking about right there. You want to show that? Yeah.
Yeah, it's one thing I'll definitely say. You guys have a lot of tiny little icons, which, you know, thank God for good vision.
Yeah, it's another algorithm. There's two algorithms for that, actually. What are you using then to get out of ZBrush and changing, converting into an IGS?
So I use Rhino when I'm dealing with surface files. Occasionally I will go into Pro Engineer. I've seen there's a number of different applications, even free applications you can get for converting them. I definitely would suggest, you know, understand your scale, and then when you go to tessellate a CAD file, try to set it to a resolution that is appropriate. If you can set it to 001 or 0001, it might be a bit heavy, but you're probably going to get a more decent mesh than if you just go with whatever the default is that it's thinking. And also that's in inches. Yes, Pro Engineer is Creo now. That gives you an idea how long I've been using Pro Engineer or Creo. Let's go up to this new one. Oop. That is a joint. There we go. All right. Bam.
There you go. Done. Ship it.
Yeah, this is one of our newest toy lines. It's honestly one of my favorites. This was actually drawn up by one of our artists in-house, Cheeto Arleno. He's the artist behind Shark Bunny. You know, he's an amazing artist, and I had so much fun sculpting this one. Let me just quickly jump real quick to my PDF here. All right, toy style. So when you're working with forms and rhythms and trying to create what I would call a toy style, you know, it's great to understand anatomy and understanding, you know, all the biometrics and how shapes work and everything. And, you know, this gives you an example of things. But something equally as important, especially in toys, is rhythm. Understanding how these shapes create a rhythm amongst each other, so that even if you don't have accurate anatomy, the overall shape and forms of it can represent that in a way that's recognizable and looks good. One of the things also that a very good friend of mine had said every sculpt he does, he tries to put a little bit of arabesque into. This is an arabesque. It's a ballet pose. You want that contrapposto, that beautiful like exchange of shapes, of straights and curves. It gives you like a full meal in a sculpture that really helps sells it. Just open up the actual design file real quick. So this was actually when I was sculpting this guy. Always sculpt them up in pieces, in big solid chunks, and then chop it up later. We actually went through a lot of revisions to try to get this arm to properly articulate just right. That's kind of a big deal for us. And as you see what I'm talking about, as far as these curves, these straight edges of getting a rhythm.
Can you show someone wanted to see if it's possible for you to show the joints so they can see what you're doing with the joints?
Oh, let me go back to that one. Oops.
What toy line is this again? Someone's asking.
This is BAM, B-A-M. If you're to look at it, you can find it on Amazon and stuff. It's B.A.M.
I'll put it in there. There you go. Bam! Wasn't just saying bam because it was there. That's the toy line.
Oops. Let's
I'll see if I can find a link to it as well. There you go. Let's see.
I think even if I go to this one, was this? Yep, that was on that. And I think actually we did revise some of these joints afterwards because we actually made them double jointed. So that way they can, fully, close up and actually grab their face kind of thing.
So I'm just seeing, is that, I think that's pretty, people are asking about that. So that should give that a result. So you're looking at seeing lollipops or no? You got some hinges in there. So how do you guys decide your articulation? Is it just right from the ground up, or is that an evolving thing for you?
It's actually a bit evolving depending on what it is we're trying to do. On some things, depending on the thicknesses of the arms and the scale, we'll have to decide, like, do we want to make it a little bit bigger and try to give it a double joint? Is it big enough that it can handle that errati? Or is it a situation where it's going to impede the overall look of the model that it's better to have a single joint? It really kind of varies, on what it is and also the type of model it is. Mm-hmm. On these ones, I think we started off with single joints and then we quickly decided we wanted to do them in a double joints, and that's why it was switched off afterwards. Let me just show. So this is when I'm constructing an arm here, and when I'm talking about looking at rhythms and shapes. Always start off as basic shapes. I personally like to have separate parts for each and one of them and actually just name them bit by bit. Let's see. I love your guys' Move Infinite.
Move Infinite, yeah.
I keep thinking of it as the Infinity Move.
Yeah, it's one of Joseph's little babies right there.
Man, a lot of requests for that one.
Yeah,
that was pure genius, man. That
was a big one. Yeah, that one's actually a big one.
We had a lot of people that were asking for it because we had it in the ZModeler brush for a while, but never had it its own separate brush.
And you can use it on any brush too. It's not just for Move. It can be used for anything. So that's how you're using. This is pretty much your go-to brush now for when you're looking at your forms, your silhouettes.
I always just look at it from every angle. Don't make one thing I used to see a lot of, like in art school, you see a lot of people do is they would start a sculpt and they would do the whole thing from one angle, and then they turn it around, and it's like, oh shoot, what did I do?
Yep. Yeah.
Constantly move. You should be constantly flipping around every which way.
Yeah.
So let me get to this.
I'm gonna put
this part right here, and I want to show creating a hard edge in places. So very common, especially nowadays, the current aesthetic of toys, you see this sort of soft, smooth, hard edges going on. When you go to put like a hard edge in something, and let me go ahead and use my pinch tool. And I just have the lazy brush on. Let me go ahead and turn that on so you can see it. And I say right here is where I want to have like a hard edge, for instance. But I didn't quite get it hard enough. Now I can sit here and try to go back and try to match that exact same place. And yeah, you can do your whole masking tricks and all that. Or you can have the lazy brush on and undo it and redo it kind of thing. Or let me just do it once. ZBrush has a repeat function that is truly underrated. Once you use something, press 1 and it will repeat it. And that is honestly one of my favorite tricks for doing these types of shapes inside of ZBrush.
You're making Paul really happy right now. Really happy.
Do you know how many times? And then don't get me going on inventory. Don't get me going on inventory right now that nobody uses. Drives me bonkers.
Another thing is that almost all tools have an opposite effect, and some people don't always notice that. For instance, the pinch tool, by default, when you go to use the pinch, it's going to pinch into the positive, but you can also pinch into the negative. So if I want to kind of drop that in, so holding down the alternate key, and then always start as a low poly, build yourself up to a high poly. Never jump in too fast. I usually like to get it roughed out first in this low poly before I start jumping into Dynamesh and starting to do other things. Okay, so starting a sculpt for a toy from an action figure. I know for a lot of people that can be kind of daunting. It's like, well, I'm going to do this whole thing. Where do you begin? What's the number one thing you do? For me, the number one thing I do is set the scale. It's quite common in the toy industry. They're going to tell you, this is a toy for so-and-so place. It's going to be X amount of size, where our package can only support a X by size, X by size, X by size. So set a reference. Create a polymesh cube. Use Scale Master, and then set the scale. As you see right here, this has already been set to I believe it's a 3 by 6 by 12. That was actually the original size for that. And if you look out over here in the back, this is actually the artwork that I had received for that model. Come over to the Draw tool. I'm sorry, Draw tab. And under front back, that's where I imported that. If you want a quick trick to getting that centered in the right place and fit out into the whole scene, make certain that your reference image is a square. Then it'll just automatically, if it's centered, it'll automatically just fill in right where you want it. And then duplicate that. Do not start sculpting on top of this. You will always come back and need that size reference. duplicate it, and work on the other part and hold on to that as your reference tool. From that point on, that's where you can build it in whichever way you feel appropriate. I definitely do like using, starting off from a sphere.
So that's your number one. That's what you're starting off pretty much a lot of time for your base. It's just a sphere, straight up sphere.
Either a sphere or a cube.
Yeah.
It's just my go-to. I think maybe because just coming from the Dynamesh days, it's just my way I like to do things. One thing I've recently become incredibly dependent on is the deformers. These are absolutely amazing.
Yeah, so he's using a lattice deformer and he's masking off the white points. In essence, the lattice points, for those that know it, that he doesn't want to move. It's a big one.
Oops.
So you always use the floor grid a lot of times for your referencing? This is your
I
go-to.
do. I sometimes, if I have a drawing like this, where the artist Cheeto actually went through and did a very good illustration for me to work off of. A lot of times I will get a 3/4 shot or just a reference shot of just part of what it is. At that point, I'll sometimes either bring it in as a on the grid, or sometimes I'll go through under texture, image plane, and just load up an image in the background. Just depends on what the reference is. And you can already kind of tell just from how fast I'm working on this. Easily, a day you can get something sculpted up, ready to go from there, and actually do 3D prints, test it out, see how it works. I will tell you right now, what you can 3D print, you cannot necessarily always manufacture, and vice versa. I really encourage anyone who's looking into toys, understand what those differences are. Run prints, compare it to actual toys, get some toys, look at them, see what comes out of a mold, see what actually comes out of a 3D printer, and understand what those limitations are.
Do you have any 3D printers that you like to recommend to people that want to get?
I would definitely recommend Formlabs actually, as far as easily accessible. Especially the Form 3 is hands down one of the best prosumer industrial level 3D printers I've ever used. I'd say maybe 99% successful. If you follow what the software says, it's gonna 90% of the time it's gonna print. 95% of the time it's gonna print. You're not gonna have a problem. Other printers, that number kind of goes down. You got to really make certain you look through everything and make certain it's absolutely functional. Other printers, when you get to more of a higher level, a little bit more industrial, one of the best color 3D printers I've ever used, and actually we did color 3D print this model, is probably the Mamaki color 3D printer. If you guys have never seen that, that just blows me away. And I've used actually almost every other color 3D printer in the industry, and that one just to me is one of the best. Its material and its color accuracy, and even the price is just perfect.
Yeah, we had them at last year's summit. They were here. They had a booth here. So, and then they had some really big, huge prints. That's done a really good job.
So before I get too worried about, getting into all the little details and shapes, I do like to try to get some basic shapes laid out for everything. You can go through and undulate and detail things out for forever, but you want to make certain everything's to proportion to each other and everything is just functional. So, even if you're just putting in basic shapes as placeholders, get things laid out, get things, built out through the whole model.
What motivated you to get started in the toy industry?
I think it's for my background and my training was just kind of a given. I come from a very traditional artistic training. The school I went to, actually, we didn't even have any computers in there. You had to learn how to sculpt in clay and marble and wax. And most of my professors, who were quite elderly, actually, they also were toy sculptors. Because for them, the past century, the 20th century, was what they called the forgotten century. They couldn't get into a gallery, but they could do toys, and they could do movies, and they could do tombstones. So it was just kind of understood from the get-go that, oh, you want to be a sculptor, you should learn to do toys. It's going to just be common.
Okay.
One thing that I gotta say I really absolutely love about this lattice cage is that it follows the direction of the gizmo. That's that's actually super nice, especially when you want to do certain types of deformations.
Yeah, I think that's a missed thing that people miss on. I love that about it too. I use it a lot like you too. This way, you got 360 degrees of symmetry now.
And just to show you what that means, so I'm gonna just go ahead and turn that off from where it was, and then turn it on, and now you see this lattice cage. It matches up with these axes, whichever way I turn it. So if you need to do a deformation in a weird angle away from default, go back to the gizmo, rotate that out to whatever angle it is. Oops. There, now it's lining up to it. One thing also, a little quick note that when I teach ZBrush in my office, I always tell everyone, and I know, Paul, you've been a big pusher of this, learn to use the right mouse button.
Yes, the army is growing.
Yeah, that's one that when I learned that years ago, I'm like, oh my God, that saves me so much hassle.
That's right, Trust. That's right, Trust. He's still the original alt navigator. We have a war going.
Yeah, I still like the alt.
I think because a lot of times when I'm shaping things out, I don't even use a Wacom when I'm just getting these shapes figured out. I'm just going to use a mouse and just kind of move things around and get the general shapes around. It's partially just because I'm a little bit more from that traditional school where you sculpt with your arm and not necessarily with your hand. So I'm used to moving my whole arm when I'm working.
You got a couple followers with you, Dross. Oh, we gotta.
I just don't like the placement of the pen. I never get those where it is. Just never. I don't know. It doesn't feel.
You never have the button in the right spot. You're saying
no.
I wish they'd make more pens without buttons, actually. I know it's probably a bad thing to say about, on Wacom. I sometimes just rip the buttons off.
They used to sell the sleeves that you could get without that buttonhole in it. I had a few back in the day that had no buttons.
How do you move around your joints within your toys inside of ZBrush when you do have joints? Is there any particular way you do that?
How do I maneuver the joints within ZBrush?
Yeah.
You want to make certain that when you go to move your objects that you have your gizmo aligned up to the same axis. So in some cases, let me see if I can maybe snap to one here. So if I go ahead and hold down the Alt key and click, it's gonna snap to a flat. When you make a joint, especially for toys, you're gonna have a flat. There's gonna be a flat part there. That is great. So now that I snapped onto it, I know if I want to rotate this along this axis, I can grab that, and as long as it's centered on to where it needs to be, see it's rotating on the axis. So hit that flat part, center it on there, and you can rotate it around. I know some people, they'll put reference objects to actually figure out those axis parts on. A lot of times, just because of, I handle things a little bit more on the manufacturing side as well, I will do some of my joints specifically in my engineering applications. And that's a little bit more on the more technical engineering side, less on the artistic side. And I know people who do a lot of their joints in ZBrush too. There's no wrong way on there. It's whatever you feel comfortable with.
Just want to give you a time update. You got about 5 minutes.
Oh, wow, that was fast.
So you know where you're at. Well, you can go a little bit longer. No one's going to say no. It's more about you.
So one of my favorite tools you guys got in here, especially for early shaping things out, is the clip curve. And this is, just really a wonderful tool for kind of shaping things. You have a lot of options you can do here with this, besides just obviously cutting. If I want to actually stop the cut, it respects your maskings. Definitely, utilize these tools. Keep the shapes basic. Don't get too much detail too fast. You can always run more. If you run into an issue like that, that's because my topology's all over the place. Now I can start dynameshing it and start to really get into the nitty-gritty of the shape. But try to keep things basic always. I think that was one of the hardest things for me to learn when I first started learning ZBrush years ago. Was I kept running the resolution up and making my life difficult until I stepped back. It's like, all right, keep things simple, keep low poly, get the general shape of it. This tool right here, the silhouette, is honestly one of my favorite things you guys added into here. Look at the silhouette from many different angles, before you really start getting crazy on stuff.
Yeah, you can even add an image to that too if people want. Do you have anywhere your work up anywhere? YouTube, ArtStation, anything like that?
I don't actually. I think it's for no other reason than just for the past 15 years, I've just had my nose down trying to just do the work. I just never really bothered to make one of those.
Well, are you always, as a toy designer, you're always perspective off? Do you ever turn perspective on?
I actually usually leave it off when I'm matching to a drawing or any type of reference. I will turn it on sometimes if I need to really kind of get an idea of how things look. I will tell you, because the toys are pretty small, it can be rather deceiving when you have perspective on. I honestly think this is maybe just something with toy sculptors. A lot of the toy sculptors I know, we almost always work in orthographic.
Mm-hmm.
So this is pretty much what you do for all your toys. You just keep adding primitive shapes, and then you're refining and shaping them with the features that you've been highlighting.
Yep, just bit by bit, just like just like doing it in clay.
Yeah.
Um,
Sometimes the simplest way is the best way.
Mm-hmm.
Just always refer back to the way things used to be done. My partner, he's an illustrator, and he likes to say that just because it's old doesn't mean it's primitive.
It's true.
And the next shape.
You don't worry about making the other side. You do a mirror and weld, or
I do a mirror.
You do a mirror.
Just because this thing is for the most part symmetrical until I get into these fine details. And in toys, you do see a lot of symmetry in a lot of places. But as much as possible, I'll try to do one side, flip it over there as soon as I have it shaped out.
We don't want to keep you all night. Just to let you know, we're at the 10 o'clock spot.
Oh, wow, that was fast.
Something else to cover too.
All right. Well, if you guys got any additional questions, this is essentially my workflow. I love how quick and fast you can build up your shapes and get your fine details and everything really just sculpted so naturally within ZBrush. So that when I have to go into manufacturing then to take this into my engineering programs or even come back and forth, the nonlinear nature of ZBrush makes that so easy and seamless.
Yeah. And again, he's having perspective off because he's dealing with a toy that's smaller and perspective has got a distortion on it. And you're not going to have that distortion in real life the way a perspective camera might have it. So obviously our eyes have a perspective. You would have to find that right one. So I, even myself, when I'm doing anything for 3D printing, I don't turn perspective on either. I keep it off. Straightforward, right? Straightforward workflow. Are there any design considerations when making toys that are specific to designing toys? For example, 3D printing, always need to worry about supports, angles, and layer prints. Is there something similar when designing toys?
So when you're designing toys, it's really your number one worry is going to undercuts, and it's moldability. Molds come in multiple shapes and sizes. You're going to have what's called like an AB mold. That's a front and the back piece. You can have what's called slides. That's where you'll have a front, a back, a left, a right, multiple different angles, and they can only come in certain angles off that part. So that will affect your detail. That's where, if you look at toys, you'll see draft fills that look like these weird flats in places, or where they fill in details. And here, let me pull up real quick. That's a great question. Let me pull up on the Bloodhound so you can see where I had to make some of those decisions.
While you're pulling that up, what do you usually yourself end at polygon counts? Do you there's there's no number because you're going to decimate it down anyway. Right?
Well, I'll tell you, when I go to 3D printing versus what you go to manufacturing, you do not want to do a high decimation. And in fact, I try not to decimate my files when I send it off to my engineer unless it's extremely large. A lot of times when it's going to go into my engineering application, they have the ways of dealing with the mesh that it doesn't matter. So, I'll shoot it over there literally in the millions because I'm not worried about that. When it comes to 3D printing, if you go below, really, I wouldn't go below half the micron resolution. So really what that means is each individual part, like for instance, an arm, I really don't think I wanted to go below 250,000. If you were able to set a tolerance with some decimating applications, you can. Say you're printing something at like 30 micron or 50 micron, set your resolution, your decimation resolution to roughly 25 micron. That way you're not wasting polys, but you're not breaking your computer either. Let me see if I can find a few sections here. I remember specifically
For the drafting. Yeah.
Yep, here we go. So this is something that I had to think about. And this is where I had to make a decision about the original IP, about the importance of how that looks, to retain that look, but also make something that is manufacturable. So you can't have these little floaters here because these things are so thin, the plastic won't be able to flow into that. It'll break right off, and it might not even be toolable or castable. A lot of times molds like these for shapes like this, they're not necessarily CNC tooled. They're actually what's called a beryllium copper mold. It's a bit of a casting process, just like if you're making a plaster mold. But you really got to consider, is this going to break off? Is this going to fill? So you can see right here where I filled things in. And that's where I just insert a cube, shear it back, try to make it fill in, and then merge it all together and remesh it.
Nice. What's the time frame for you to get before the toy hits the shelf? When you're
So that's varies dramatically from brand to brand, from licensed brands to other things. So that's gonna be all over the map. You can have as little as 3 months and as much as a year. It's hard to say. It really depends on what it is. That's where you go beyond what you're actually sculpting and making it more into the sales, the marketing, and mine's smarter than mine to figure out that kind of stuff.
right. Well, Ali, I don't want to keep you all night, so we went extra. So I thank you for being here with us.
Thank you.
Tonight. That was awesome.
Thank you guys. This has been such an honor. ZBrush has been part of my life every night, every day of the week for years.
And now we've seen the home office that you're doing it all in too.
Yeah.
Yeah.
Look at me now.
I think you gave a lot of really good toy information that people, those that are, especially people were asking, how do you get into toy? This is one you should go rewatch. He gave you a lot of valuable little things that are important for toy making and toy designing. 100%. Huge stuff in there. So thank you. I really appreciate you taking time out of your evening, being with us. It's been awesome to have you. I don't know if you want to end on anything, Ellie, or anything extra you want to throw in there.
Just my one major tenet. I always believe you use tools to achieve your goal. You don't make your goal to use tools.
Nice. That's a good one. I like that one. That's awesome. Well, Ellie, I can't thank you again. And
yes, thank you
too, for letting you also show all these lines that you guys have been working on. It's really awesome to see everything. We still got stuff to give away, and I can't help myself. I got to show something that Joseph made me, just got me going again. I got to show one more thing too after this. I just got to. I got to help myself. All right, Ellie, thank you so much. Again, it's been awesome having you.
Yes, thank you.
So glad we're finally able to get you in the summit. It's been great.
Thank you.
Thank you. Okay, I got to do it. I'm sorry.